Hello, so in this video I'll be talking about how I did a Verilog synthesis and simulation in Vivado for a microprocessor alarm system. After creating a design source, which is located on the project manager bar, you are required to put in parameters. And I put in LWTP as my input and X as my output. And then you'll see that in the text editor right here, there should be a time scale at the top, and it shows that there is 1 nanosecond for every lap. And in line 23, we have our module with 4 inputs, L, P, T, W, and output Y. We assigned output Y to this expression, and this expression is supposed to satisfy all the conditions given in the project. And from here we can generate a schematic, and you can do that by pressing schematic under the RTL analysis bar, and under elaborate design press on schematic, and you will get this right here. It should have 4 inputs, W, L, T, P, some inverters, AND gates, OR gates, and an output Y. You can also generate a different schematic by pressing schematic under the synthesize design under synthesis. And this creates this schematic. This would be a block diagram. And there are some buffers, input buffers right here. Buffers actually act like registers, and it stores output values that can be read back into the code. There's also an LUT, a lookup table, and it is implemented by our truth table. There's also an output buffer and a output Y. Moving on to our timing diagram for our original expression, you will have to add another resource, but this one would be a simulation resource. You will also have to put in parameters, inputs and outputs, and then you'll get a text editor right here. You would have to turn the inputs into registers by putting reg, and the output into wire. And then we would have to build a unit under tests by calling our main module to map the port with the registers right here. Here we would add all the values for LPTW from our truth table, and here I added a delay that is set to 100 nanoseconds. After that, we would have to run a behavioral simulation. Here we can see a timing diagram. Here are some values, 0, 0, 0. And then we would have to repeat this process for our simplified expression. we would have the same inputs. We would assign y to a different expression. This one's the simplified expression. And you can generate a schematic under the RTL analysis bar. And this is our schematic for our simplified expression. There are 4 inputs, but it's because the expression does not have W, as you can see here, so nothing is connected to it. There's an inverter, some AND and OR gates, and a output Y. The test bench should be the same with the previous expression, the original expression, and the truth table should end up being the same. So, all in all, besides the code and the schematic being different, the timing diagrams, the outputs for the timing diagrams are the same. And this is how I created a system that notifies a microprocessor to activate alarms when chemical tanks are in critical conditions. Thank you for watching.